Hello there and welcome to this video series on control systems. Over the past few videos, we have been looking at Laplace transforms of time domain functions. Using these Laplace transforms, we can derive what is called transfer function of a linear time invariant system. And once we derive that, we can use a few techniques either to analyze or design control systems. With that in mind, we'll continue a couple of more examples to see how we derive Laplace transform. Basically, it all involves integration between the limits 0 to infinity. We'll go through the videos one by one and try to see that over the past one video or so, we have derived the Laplace transform of a unit step input by using this formula. Given a time domain function, multiply by e power minus st, integrate between 0 and infinity with respect to the variable t, and you have this fs. Note that lowercase letters indicate time domain function, uppercase letters indicate Laplace domain function. This s may be called Laplace operator or Laplace variable. With that, we will see one more example, and perhaps these examples will help you derive Laplace transforms of a few complicated variables, complicated functions. We'll see this function which increases linearly here after time t greater than or equal to 0 and is 0 all towards the left hand side. You can see t is equal to 1, ft is equal to 1, t is equal to 2, ft is equal to 2, and so on. So ft is equal to t when t is greater than or equal to 0. So while integrating between the limits 0 to infinity, f of t is t. And with that, you will evaluate the integral by integrating by parts. You have this t power minus st by minus s and minus this whole multiplied by derivative of t, and thus you have the integral 1 over evaluated to 1 over s square. So f of s is 1 over s square. This function f of t is called unit ramp input. Okay. Next, we'll consider a sinusoidal function. That sinusoidal function is sine of at, and in place of f of t, you put sine of at, and e power minus st sine at integral we have already defined, and we evaluated between infinity and 0. And at infinity, this e power minus st is 0, so the whole thing is 0. At 0, you have this e power minus st is 1. This sine at is 0. So we are left with a over s square plus a square. So we will leave this video here. Maybe in the next video, we'll see a few properties of Laplace transforms, and then we'll go on to inverse transforms. That's all we have for now. And we will continue this Laplace transform and inverse Laplace transform in subsequent slides. That's all for now. Thank you so much. Have a great day.